So to set up our process for how we're going to subtract vectors algebraically, let's actually step back and remember how we said we were going to add vectors algebraically. So our general process for vector addition was we were going to start by drawing a couple of vector diagrams. We're going to pick a coordinate system. We were going to use that coordinate system to break our vectors up into components. We were then going to set up a set of component equations, so one equation for each axis, coordinate axis that we needed within the problem. And then that was going to leave us with a set of equations with a set of unknowns that we would go and use our algebra to solve for what the unknowns are. Well, so if that's our process for adding vectors, what do we do to subtract vectors? So to subtract vectors, our general process looks really similar. We're going to start by drawing some vector diagrams. We're going to pick a coordinate system. We're going to use that coordinate system to break our vectors up into components. We're going to set up a series of component equations. So again, one component equation for each coordinate axis that we need in the problem. And then that's going to leave us with a set of equations that'll have a set of unknowns, and we'll use our algebraic techniques to solve for what those unknowns are. The real fundamental difference between these two processes is that in step 4, instead of setting up an addition equation, we're going to set up a subtraction equation. And that sounds trivially simple, but as we'll see in a second when we look at an example, we just have to make sure that we take care of all the minus signs that are there in the problem. So let's look at an example. So let's say we have two vectors. So vector A has a magnitude of 12 newtons and makes an angle of 25 degrees above the positive x-axis. Vector B has a magnitude of 8 newtons and makes an angle of 20 degrees to the left of the positive y-axis. What I'm interested in calculating is vector A minus vector B, and so I'll give that a name, vector C. So the equation that we're going to set up here is A minus B equals C. We just have to set that up as a vector equation. So we're going to start where we normally do. We're going to start by making a vector diagram. Here again, we've basically already been given that vector diagram in the way that our vectors were described to us. The one piece we will add is we'll go ahead and draw in vector C. And since vector C is vector A minus vector B, we're going to start at the tip of B, draw to the tip of A. So vector C points from B to A as they're both drawn from the same origin. Step 2, pick a coordinate system. Again, that's largely been given to us, so we're going to have our standard coordinate system of positive x pointing to the right, positive y pointing up. Step 3, we want to break our vectors up into components. So again, we'll make a table. We've got two coordinate axes that matter here, so we're going to need to break things up into x and y components. Vector A, it points up and to the right. It has a magnitude of 12 newtons. It makes a 25 degree angle with the positive x-axis. So I know the x component of vector A is going to be plus 12 cosine 25. The y component is going to be plus 12 sine 25. Vector B, it points up and to the left, has a magnitude of 8 newtons, makes a 20 degree angle with the y-axis. So I know it's going to have vector B will have an x component of negative 8 sine 20 and a y component of positive 8 cosine 20. Again, the equation that we're setting up is A minus B equals C. And when I think about vector C, well, I do have some sense of its general direction from my diagram, but I don't know any of the specifics in terms of either its magnitude or direction. So we're going to do what we normally do in that case, and we're going to leave vector C just in terms of its x and y components. So step 4, set up my equation. So again, I can set up an equation. I need to set up the x component equation. So that tells me that the x component of vector A minus the x component of vector B equals the x component of vector C. And again, plugging in what I've got in that column on the left, that's going to be 12 cosine 20 minus the x component of vector B is negative 8 sine 20 equals the x component of vector C. And so here's what I was talking about a minute ago in terms of we just have to make sure we're keeping track of all of the minus signs correctly. This minus sign comes from our subtraction problem. This minus sign is there because the x component of vector B is negative. But I know that when I deal with this equation, these two minus signs are actually going to cancel out and leave me with a positive. So now I can come back and set up the y equation. So I want the y component of vector A minus the y component of vector B. That's going to be the y component of vector C. And again, that's just using the information that's in the column on the right in my table. And so I've got 12 sine 25 minus 8 cosine 20 equals the y component of vector C. So I've used the components of my vectors to set up two equations, an x component equation and a y component equation. I have two equations. I want to identify my unknown. What I notice is that my unknowns happen to be the x and y components of vector C. Each unknown has its own equation, so I don't have to do anything sophisticated in terms of calculating out the answers for my unknowns here. I can just go ahead and calculate out that the x component of vector C is 13.6 newtons, the y component of vector C is negative 2.45 newtons. So once we've calculated out the components, it's useful here to go ahead and slide vector C down so that it's now also sitting at the origin. And that makes it easier to see what vector C's x and y components are. And so graphically I see that vector C points to the right, the x component of vector C points to the right, the y component of vector C points down, the x component of vector C is relatively large, the y component is relatively small, and all that's consistent with what we've just calculated. So again, I have a relatively large positive component for the x component of vector C. I have a relatively small negative component as the y component. So the important takeaway here is that the process for vector subtraction is fundamentally the same as the process for vector addition. I'm just setting up a subtraction equation, and so therefore have more minus signs that I need to make sure that I take care of correctly when going through and setting up the equation and then doing the algebra.